Learn C the hard way, exercise 36. We're going to cover trying to make C's strings safer. You cannot make C strings safe. They are not safe. C is not a safe language. It is because of undefined behavior that we covered, because of wild pointer access all over the place, because of no bounds checking on any loops or any pointer access or any array access, and because of the way strings are structured with the terminator, they are just broken. So we're not going to be able to make safe strings. It's not like Python or any other language where the strings are implemented. Actually, any other language after C, really, where the strings are implemented correctly so that you can't break them. So the plan is we're going to learn about alternative string implementations. I have one that I use that I like, but I'll show you another one to avoid most C string problems. But notice it's most, not all. C strings are just bad. Okay, it is impossible to safely process strings in C. This is something that I'm just resigned to. I used to think you could do it, but I'm now convinced that it's impossible to safely process strings in C. I think you can get a code base using strings to be mostly safe, but there's so many bugs, especially so many security defects these days, where strings and memory access, I'll lump those together, just are broken in C. They would just have to accept that after decades of C constantly being broken, that they're broken. C strings are broken. And this is one of the reasons why I try to tell people don't really write new stuff in C. There's plenty of alternative languages out now like Go and Rust that are just way better and don't have these same problems. So why do I say C strings suck? Well, the reason why and why it's so important is C strings are the entry of an external attacker into your process, into your program. Because the strings are externally controllable by an external attacker, that's the first place that you always have your problems. Also, external attackers can control pointers if you have protocols and things that allow pointers to be, the locations of pointers and the sizes of arrays to be determined by external input. So C strings, trying to make those safe is your first line of defense. Trying to have a strict string discipline is how you prevent external attackers from attacking your C code and overriding the null terminator, or just don't use the null terminator, and attacking your code. Now, they can find other undefined behaviors like pointer access and things like that. But if you eliminate the most common entry into your process, which is the undefined behavior of a non-terminated C string, then you have your fix. However, the problem is when people say, when you go and you say C strings suck, they go, well, that's undefined behavior. The problem is some undefined behaviors are controlled by an external attacker. And some undefined behaviors are just because the programmer wrote code wrong. For example, if I use a pointer wrong, that's something I did. But if I have a C string that has a null terminator given to me off of a socket and the null terminator is gone or gets clobbered, that's accessible from an external attacker. And that's the problem with C's undefined behaviors, is they allow external attackers to trigger undefined behaviors that the compiler can't protect against because it's at runtime. So anyways, I actually would love to write a whole book about how this is so terrible, but I don't have time. So let's cover some libraries you're going to use. So the library I like to use is called bstring. And I'm not sure why I spelled that wrong, but it's not called bstring. It's called bstring. The better string library. And again, everyone doesn't say the best, the completely bulletproof string library. It's impossible. It's better. It's relatively better. Okay? And this is a fairly simple, fairly portable library. It has a whole bunch of really great stuff. I believe they've updated it recently, so you can actually upgrade it if you want. I'm using a particular version in mine that I may actually eventually upgrade to, but we'll see. And another one from the and HTTPD project is called vstr. Now, vstr was a little too complicated for me, and I didn't particularly like how much of it had. It was just a very weird library to use, and it wasn't too compatible with a lot of other things. The bstring library was just a lot easier to use, but you should check this one out too. I fully respect this code base, and I think it's a great code base. So, please check these out and see what you can do with it. If you like this better, then use it. I'm going to be using the bstring library throughout the rest of the book, and an older version that I know more or less works. But you should be able to get this, and should be able to upgrade to the more recent one. So with that out of the way, those are the two I like, but there's quite a few alternative string libraries out there. It's basically an entire cottage industry of these rose up out of nothing. So really quick, the most common operations you're going to do are bfromcstr, block to bstring, bstrcpy, bassign a cstring, destroy, concatenate, and comparisons. So that's the most common operations you have to do in almost all C string libraries. And with these, you shouldn't have to use any of the normal C string libraries. So we then get into finding a string, finding it inside of it, splitting a string, and we do this in the final project to do protocol parsing. And basically, the splitting of the string returns a new data structure. bformat is how you would format template strings. It's similar to sprintf, but it's a lot safer. And you have your length and your data, and then getting a character out of a bstring. So that's pretty much the thing, but you can just study the bstring library. So I'll load up mine, which is, slightly different than what's on the official page right now. There we go. And pretty much you just go through each function and, check it out. How does it work? How does that work? How does these work? Study these. Because you never know. You might go through here and might learn a whole lot about how to process strings. It turns out to be a lot of code, a ton of code to make C strings safer because they are so poorly designed. Okay, extra credit. There's only one extra credit, and that's to write a bstringtests.c file. Your goal, and the bstring project comes with one. So if you wanted to cheat, you would just drop theirs in. And actually, I think I've done that in the Learn C the Hard Way. But you should go and write a test for all the functions that you can see in there that are interesting, or just try them all. So that way you get used to writing tests for old code, because that's a really common thing you have to do in C projects. And that's the end of it. Read the book. I cover a lot more with C strings, but we'll be using these quite a lot, and you'll see how I use them. And you can try any C library you want. Just avoid any of the str functions. And here, I'll show you what I mean. Okay. All of these common C functions, if you use the version without the N, you are going to be in trouble. But you should just not even use these. These have so many problems and so many edge cases and so many weird things to them that you're better off using a library that just avoids all of that. So any functions that have str in them, avoid. And in fact, I have a make check. And what that does is, let me cat out my make file. It looks for all the functions that have str, cat, xform. These are all the danger functions, and it just looks for anything that looks like that, so I can go check it. It's a very simple check that helps me avoid using bad functions that you just shouldn't use. Okay, well, that's the end of this lecture.